enumerations. Enumerations is one of the first custom types we created ourselves in Swift, right? Tomorrow we'll see structs, and later in early next week we'll see classes. Today you guys got a brief glimpse into classes with David. But those are three fundamental types in Swift. We have enums, we have classes, we have structs, right? Those enable us to build bigger projects, right? Next week, we'll start seeing how we could build projects in an object-oriented way. We'll start talking about object-oriented programming when we start talking about structs, maybe even tomorrow, where we build like a simple little application, breaking up the files, and also talking about object-oriented programming, right? Where you have some sort of problem you want to solve, you start thinking, oh, what are the objects of my problem? And each object has its own struct or class or enum to represent that object. We'll see what that looks like when we go into demo, right? But now that's the theory part of it. Enums, structs, classes enables us to build more robust objects. So far we building projects where we have everything in one file. This is very procedural, right? You do step 1, then step 2, step 3, step 4, right? But with functions, classes, structs, we could build more robust applications, right? So we'll see what that looks like, especially heading into next week and heading towards our assessment. We said enumerations are a type that groups common related values together. We saw the compass, we had different directions on our compass. We had north, south, east, west, right? We saw days of the week. Those are great cases for enumerations, or enums for short, right? Today we'll continue talking about enums with some more complex functionality on the enums itself. So let's go to our playgrounds. And let's start out with declaring an enum. We use the enum keyword. We start our name with a capital letter, not a lowercase letter, a capital letter, so it lets our readers know it's a type. If string started with a lowercase s, it would be a bit confusing. But string, int, bool, all those start with an uppercase letter. Everybody with me? So the person reading it knows exactly, hey, this is a type. It's a type that I could use. It's not a variable, right? It's not a function name. It's a type. A type is, example, an int is a type. A string is a type. Our type we created yesterday, those are also types. Compass point is a type. The type we're creating now is also a type. We name it with an uppercase letter. So here we have empty lines. So our enum starts with the enum keyword, followed by the name of the enum, followed by open curly bracket, close curly bracket. Each scenario of that enum starts with the case keyword, right? Again, enums are finite. They're great models for finite objects. Yes? Oh, what do I have? Empty line, sorry. Thank you. Empty line, that's fine. Thank you, sir. So, yes, so we have empty line here, and each line will have its own case. Thank you, Adam. Right? So our empty line is finite. There's only so many trains we have in New York City, correct? So here, let's list them. We start off with a case. We say case red line, case green line, case purple line. We love that one, do we? Case blue line. Case orange line. Case brown line. Case yellow line. That's my favorite, actually. Yes? Yes. Thank you for reminding me. Yes, it's, what's that? What's the question? Gray line. Oh, like the shuttles and stuff? Okay. Oh, right, the L. I forgot about that one. Does that still exist? Those are trains, empty lines, right? Right, we have the orange, which is the F, the B. The B? Does the B still exist? The M.
So that would be like the two
Yes, exactly. Right? Are you from New York? um, cool. So here we have enums, right? So far, so good, everybody? Great. So if, for example, our user wants to create, or we have an app, picture we have an application, it's called MTA info, whatever it is, and I want to see a particular line, right? So the user goes and they create an instance of MTA line. We saw instance yesterday. An instance is you create an object of the thing, right? You create a variable or a constant of that object. That's an instance. If somebody tell you create an instance of it, you say var the name or let the name, right? Everybody with me? You create it. Instance is to create. So here we'll create an instance of an MTA line. We'll call it train. We use our custom type called MTA line, right? And we call it yellow line, for example. Great. So the user has entered some train. We don't know what train the user entered, but they entered some train. They want information about that particular train. That's what line 16 is doing. When we get into app development, we'll see, or even read line, right? If Playgrounds was to run read line, our user enters a particular train. For that example, the user entered yellow line. Everybody with me? So yellow line got created, we instantiated yellow line. How can we figure out which line it is? A switch, right? So we'll use a switch here on train. Right? For the purposes of the exercise, we'll just do two cases for now. So we'll say case red line. So we said we could use dot syntax, correct? Because now we know what enum we're going through. Yes?
Actually, on this one, it did by itself. I guess I was having some class and I just put RGB capital L.
Great. So it knows. Exactly. Thanks to Xcode. When it works, it's awesome. So here we know what train, what enum we're switching on. The compiler knows that. So we do not have to explicitly say mta.yellowLine or whatever for the case. We simply say dot red line. Right? In that case, I'll have a print statement here saying the 1, 2, 3 trains are available or are running on time. Right? Case yellow line, I'll simply print the R train is not running today. And I'll have a default. Currently, our switch hasn't been exhausted yet. We agree? We haven't explicitly written out all the cases for our MTA line. So for now, we could simply say default if we want to stop at this point and just say all trains running normally. Right? So we have enough code now to test our switch function. We could run the play button on our playgrounds. Right? And indeed, we see the R train is not running today, right? Which is not, I'm not too happy at this point. Everybody with me? So I was able to switch on my train using a switch statement, go through some cases on my enum, and see which train is being referred to. Everybody with me? Great. Any questions? Any questions? Okay, let's take it up a little bit now.
So, and this is, again, this is a case that train is equal to reline, where reline is the user asking whether it's
Yeah, like you instantiate it, so it's coming from a user in that case, right? Picture it comes from a user. Because it's hard to show enums without having some sort of interaction with it, but for there, that's the interaction. Cool? So if you had read line, the user would enter some subway line or your app, they select some train. Cool. Now let's see what the next topic will look like. Let's add associated values. We haven't seen that yet. So we'll talk about associated values and see what that means. Associated values. So far, everything we've seen today, we've seen yesterday. We saw yesterday, right? We saw how to create an enum. We saw how to use a switch statement to go through an enum, right? We saw the dot syntax on an enum, instantiating an enum case, right? So now let's talk about associated values. Wouldn't it be great to associate or to bundle a value with one of those cases? For example, our purple line, right? Purple line doesn't say much, right? Or red line, we know there's multiple trains. Do we agree? Right? We have the 1, the 2, the 3. So we could use associated values to expand on an enum, right? I could use associated values and give this more values, basically. Give it more access. Give it more objects that's associated to the red line. So not just red line, but red line, what line is it? I mean, what train is it? Is it the 1, the 2, the 3? Right? The blue line, is it the A? Right? Is it the C? Is it the E? Which train are you referring to on the blue line? You with me? So we'll give our enum more flexibility and more functionality by using associated values. As the name says, it associates more values. It adds more values to the case, right? So you could say adds more values, or more values, more types to a case. Right? So for now, we have our yellow line. I could have an associated value. The way you have, or the syntax for associated values, you start with a parens, an open parenthesis, and the type that you want, in that case, I want the type to be, what's a good type? What's a good data type for that? To represent the yellow line is all what? Characters. Excellent. So I could use a character here. Right? So my yellow line, I use a character to represent that particular yellow line. It could be the R, it could be the N, it could be the Q. The W still runs, right? The W still runs? Could never remember sometimes. Question?
At first I was going to ask if the character was for the name of the string.
Yes, for the name of the character.
For the name of the character.
Do we use character for the 1, 2, 3?
Okay, what would we, which one? The red, right? What's a good data type for a red line?
Integer.
Integer, right? Double, huh? We'll get there one day. Cool? Do we have anything different here? That's it. Cool. So we could ignore the rest for now and then know that you could add, you could not add. It's not all required, right? For red line, we added the integer. For yellow line, we added a character, right? We could add a character for gray line too. But no, the point of this is to know how to use associated values. Here, I associated a value with my case for red line. It's an integer. I associated a value for my yellow line. It's a character. So far, so good? Oh. That means when we instantiate it here, we should get an error now, right? Because this guy is complaining now, right? Our yellow line is missing context. Our yellow line needs to have a character, right? So let's go back and fix our code. So far, did you guys add the integer for the red line? No, add int. Okay. Do you have a character on your yellow line? Okay, let's go to fix our code now. So where it says let train equal to empty line, yellow line, let's redo yellow line here. We're going to fix the errors. Those errors you see in there. We'll fix them now. So empty line, we'll start with yellow line. You see our yellow line now provides a character. So we could enter. Do we see that? Right? So yellow line, go ahead and press enter. For our character, put our train. Right, everybody? At this point, all your errors should be gone. So far, so good? So far, so good. Yes. When we're assigning it to train, you mean this here? Instantiating. Instantiating. So here we are instantiating a train using the. We're telling the yellow line what type of train it is. The way we did that is using an associated value called character. So we could bundle our train with more information. We bundle the yellow line here with more information. Before it was only a yellow line, correct? It only said yellow line, so far so good. Now I have more information from the case, which we'll see later in the switch statement how to use it. That'll give you more, that'll answer your question better. And we'll come back to it. Cool, Amini? So far, is that, I'm sorry? Are we all okay? Do we still have errors? The errors should be gone by now. So far so good? Okay. So now we instantiated our train using MTA line here. We have our train. Let's go to our case where it says yellow line. Everybody with me? Okay. I could unbundle what was in the yellow line using a variable or constant. The way we do that, I'm extracting the value. I want to extract what character, right? I want to extract what character that yellow line is. Is it the N? Is it the R? Is it the Q? Everybody with me? The way we go about doing that, right after yellow line here, right? You could put in let train name, for lack of a better word for now. Right? Not equal. The power of associated values, it knows its internal values. Right? It knows its internal values. You're the one that provided it here. It knows about its associated values here. Right? So if you want access to this variable that you passed in, the R, you give it, it could be any variable name. We know that from now, right? Any variable name is up to you. It could be a let, it could be a var. If you don't plan to change it, make it a let. Everybody with me? And now we could use train name to string interpolate in here. Before we had hard-coded the R. Everybody with me? Now I could say string interpolation, train name. And I could run my program again. And I see the R train is not running today. Everybody with me? Go ahead and change R to Q and run the program again. Everybody did that? It changed to Q train, correct? Okay. So Q, and then just run the app again. Cool? So that's the power of associated values. They're very powerful. So on top of enums, which is powerful, it may look simple, but it could be a very powerful data type to use to accomplish certain things. You have some case, you could bundle it with more things. I could even bundle it with a time. What if the train stops at a certain time? I could put that here, right? So the yellow line, I could put more. I could put like an int, for example, here, like start time and end time. I could also name, give it a label. I could say start time, time. And I could say end time. Our trains don't end, but just like for illustration purposes. Train name. So the same way we could give our tuples names, we could give our associated value types names, right? Like a label name, train name, start time, end time. Now we have an error because we have more, we're missing variables here. We're missing arguments. So let's go ahead and update. Do we have a question? Okay, let's go ahead and update. So make sure that your yellow line now has 3 associated values. We have character and we have 2 integers. So far, so good? So far, so good. Again, for illustration purposes, if our train was to start at some time and end at some time, let's go ahead and do that here. So we have 3 arguments we have to pass in. We have some train, we have some start time, let's just say 8, and we have some end time, let's say 12. Right? So now we have 3 associated values. We've given all those 3 associated values actual values. We give the first character R, start time 8, like 8 a.m., and end time 12, right, like 12 a.m. It's up to us if we want to use it in the switch statement. Everybody sees that, right? If we want to extract those values, it's up to us. How we extract those values, we use a comma after train name here. I would say let start time. Again, it doesn't have to be the same, so I'll just say S time here for us to make sure that it doesn't have to be the same as those things we did up there. And then next one, I will say end time. Right? Yes?
So quickly, instead of writing case yellow line character, integer, and integer, could we immediately put already that characters and some integer already?
You can. I wanted to just show us 1, then 2, then 3. You can do everything at once, but I want to break it down simpler for us to digest it. Does that make sense? Yeah, cool. All right, so now let's redo our print statement for the yellow line. Just redo it. Yes, question?
So when it's just when you just put one name, does that mean the entire
Enum?
variable?
When you put one name.
Like, because when you put let training and then let test time, it's like it's not completely reference other. So when it's just one, does that cover the whole thing?
What you mean like one case here?
No, like just now, go down,
What line number?
26.
26.
So when you have just let training, it's fine. But now that we have 3 different,
We haven't used them. You mean the yellow, the warning?
no, not the one. When I tried to put just let X time, it said that it was put let, like another one for the last part of it.
So you're saying if you have only one, you got an error? Like this?
Now it's, yeah.
Only 2 like that?
So when it's just the one, then it covers the entire.
Let me see this, 1 second. So you had one, we had one earlier, right?
Yeah, no,
Start time. That's interesting. I'll come back to you with that answer. Okay? What did it say? What's the error? Interesting. That's an interesting case, edge case there. So 1 or all in that case, right, Chelsea?
yeah.
I'll come back to you for a better answer. Is that fair?
Yeah.
Okay.
But it makes sense because when you run it after, like if you don't put all of them, it's still correct all of them.
Okay.
So it's just a
Got it. Okay, cool. All right, so let's do let end time here. All right, let's string interpolate it. So X train runs from sometime to sometime. So let's go ahead and string interpolate it. So train name runs from start time to end time. And here we could say AM to AM. Run our playgrounds again. And this time we get out, well, it should be out train, sorry. Out train. Run it again. So here it says our train runs from 8 a.m. to 12 a.m. All right, everybody got that in the console? Everybody got it in the console? Not yet, okay. We'll wait. Yes.
All right. You can only
Listening.
use like the switch statement behind it, like right behind it, right? You can't put any code in between.
No, you could put code in between. You could put code in
So
between
once
here.
the end is declared, you can refer to it.
Yeah, as long as the enum is accessible in that particular project. Yeah. 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 Cool. It doesn't have to be directly after. We're only doing enums today. That's why we're doing everything directly after. Yeah. Good question. Any other questions? I'm using the switch statement, yes. Which case we're looking at? What train it is? Right? It's hard to conceptualize it. I mean, I get it, right? Because we have a train we created already. We know what train it is, correct? So why should we go through some switch again to look at what train it is? Does that make sense? But when we start making more robust applications, we don't know what the user entered. Yeah, we don't know what the user entered. The user entered some train on line 21, right? What information do you give them back? How do you give them that information? That information, you use a switch statement on what train the person passed into your application. You have your read line happening. The user entered some train. There's no way to know unless you use a switch statement. Everybody with me? Right? It's like one of those projects where showing a full application, you'll get more context of it, right? Maybe Monday we have some time for that, or Tuesday, right? We build a project using enums, using structs, using classes, everything in one, so we know how they work together. Does that make sense? My read line, my user enters, like, what train are you interested in? They enter 7. Then now you have to give them some information, right? How you give them the information, you have to use some switch statement. What train did they enter? How do I know? I have the cases. How can I know what train they entered? I go through a switch statement. I see the train. I see what cases. Like, is it the red line they entered? No. Is it the yellow line they entered? Yes. So you print back to the read line or to the console, hey, your train is running from X time to X time. Again, we've seen a lot of tools we haven't really used yet. So an enum, you group similar values together, right? So you're making a compass app, for example, right? You want to extract where north is and have some associated value to it, right? Maybe some temperature, some weather, whatever you want to associate with that particular coordinate there. You use an enum, you group the values, north, south, east, west, or south, southwest, whatever you want to do. You run your application. When the user selects a specific compass point, you get back all the information from that enum, right? Again, it's abstract now, but we'll see more examples of it. Does that make sense? Okay. We'll see a function into an enum very soon. Cool? But you could pass enums. Enums are first-class citizens, same as closures. You could pass an enum into a function parameter or function argument. Yeah, like take train and then print something. For example, I could say simply, I could write a function here called train information, right? And train information takes an enum. It takes an empty line. And instead of having our switch statement out here, we could have it inside here. Like that. And also, I pass my train, I call my function. I could call my function now, it's called train information. I pass it train, like that. Right? So here I've defined the train, Luba. I have a function called train information that takes in a train of type empty line. I went ahead and I called my train information here. I passed it the train, and the output will be the same like we had before. I run my app again, and now our train runs from 8 to 12. Cool? Everybody? That was a good question, right? Lubo was asking, can you pass an enum into a function? Yes, you can. right? All the types we've seen you could pass into functions. They're first-class citizens.
Change this output to the type of
To change the output, you mean a different train?
Yeah.
I could just pass in a different train. Like now, I could create a new train. Like let's create a red line, right? You guys should probably be typing that too as you're asking it. So I could create a new line. Let's create a new line. I'm creating a new instance, by the way. So this is a new instance of whatever, call it one train, for example. And one train is an MTA line type. So far, so good? And this one is a red line, and I give it 1. Everybody with me? Everybody with me? Can we see the whole function? And the same way, Luba, that I call train information here and I passed it train, I could call my function again. And this time, what am I passing it? One train. What's the expected output? What's the expected output? For line 35, everybody, what's the expected output? Right? Everybody sees that? So it sees red line here. Right? So if you run the application, the 1, 2, 3 trains are running on time. Cool? So, Amini, does that help you a little bit with like conceptualizing what's happening? A little bit? Again, we'll have time for read line on Monday, where you'll see the user's input. You can try it yourself, right? You know, repeat while or whatever, have the user enter some train, some number, some character. Take that character, put it into the train that you create.
No, I understand how I could get that information. I'm just saying, why would I use this over, for example, just using the switch statement and,
Over an array.
yeah,
Okay, an array holds a collection of items, right? They're not similar items, right? They're the same type, but they're not. As long as they're strings, they don't have to be compass coordinates. You with me? So I have an array of whatever points, right? That doesn't give me much information, right? And to also extract information from it is not as easy as what we did with the switch statement. It's finite. The enum is finite. It's easier to use as far as like an object, right? An array is a collection, like a bucket of stuff. You put stuff in there, you take it out. It doesn't matter. But if you want to group items together that's similar, you want to go to an enum. The trains, for example, I could put the trains in a dictionary, right? Now I have to use an optional binding or whatever to get the key out, right? It's harder to use, harder to be reusable, right? The functionality of it is not there anymore as an enum is, right? An array, the same thing. I have an array of what? What would it be? Like array of R, N, Q strings. How do you associate anything with that? It gets harder, right? A dictionary, same thing. I could have key value. I could have the key being R, the value being some sort of information stuff. You have to grab it out of the key. You have to use optional binding or something to get the value out, right? But that one is exact to the point. I want to have a collection of trains. I put it in an enum. I want to have a collection of programming languages. I put it in an enum. Does that make sense? Sure? Okay. Scroll up to what? The function starts 24. Aha, I know. That's all we have in the function, just the switch statement. Cool? Are we comfortable with its associated values? If we were to put one train in the switch statement, here. No, but wait. Before we say that, we actually do put one train in the switch statement. When you call it on 35, right? Let's walk through this, everybody. When we call 35, when we call our function, isn't the one train being passed into the function? If we don't see that, we have to step back a little bit. I'm calling number 35. I'm calling train information. What am I passing it? One train. Walk with me. When I pass one train here, what is the value of train? What's the value of train here? It's one train, right? Right? What am I switching on? If I execute line 35, what am I passing in? What's my argument? One train. What value does one train have here? One. What case, when I'm here, what train am I switching on? Red line, right? Everybody with me? Your function gets an argument, you pass it in. That argument here, it represents the one train. The first train represents, let's rename our first train. Let's just call it our train. Refactor it, command, edit scope, call it our train. Because we had one train before, that was fine, just train, but now we call it our train. Make sure you refactor that so we lose confusion there. Should I slack out the code? How are we doing? Yeah? Okay. Say that. Yell at me. All right? Okay, so let's slack that out and create, code. Okay, so I slacked that out. I'll give you guys a couple seconds to get it all working while okay? I slacked it out. Any questions? There was the next question before I slacked out everything. Yulia, you have a question? Oh, we just created the next train. We did one because our associated value is an integer. It expects an integer. So we just say 1. We could say 2 or 3, right? The red line has 1, 2, 3, right? Everybody with me? Number 1 just signifies when we want to print it out here. Remember we had used let, some train name, and then we print out the value. If you want access to the value in the print statement, you would use a variable here, like we did earlier, like we did down here. Right? They would have an option. They would have an option to enter something. They could enter 1, but they also have to enter what line it is. Yeah, 1 is not enough information. Cool? All right, I want to give you guys a task to do. So use associated values, create, let's see, which line should we go with? Doesn't really matter. Create a character on the green line. Create a character on the green line. Instantiate, so that's what we're doing. We're doing a bunch of things here. So 1, add an associated value for green line. We have G, what else we have on the green line? 4, 5, 6, right, sorry. Just make it int. Forget about the G train right now. Add associated values for green line of type int. Of type int, right? And you could use 4, 5, or 6 to create a new instance of a constant named, just make 5, just make the 5 train, okay? And next step after that, using our train information function, pass in the 5 train instance. Cool? We know what we're doing? Okay. Okay, so we add an associated value on green line. This is green line here. This is green line. Add an associated value on it. This is an associated value, right? Integer here. So you add in an associated value on this one. It's type integer, right? And go ahead and create an instance. This is an instance. The variable or the constant name will be 5train, and you pass in the number 5. And then you use our train information function, right? And pass in the 5train instance that you created. And lastly, add a new case in the switch statement. In the switch statement for green line. Yes? No. Just keep it simple. Just one associated value. If you're comfortable with start time, end time, great. But one for now. Let's make sure we understand what associated.
On line 29,
29.
you don't need the parentheses. Down red one, because we assigned integer.
Oh, remember we said it's optional if you want to use it or not?
Okay, so,
Yeah, it's not required.
alright, so if it had like even
Yeah.
multiple parameters, you can still leave it.
Yeah, you could ignore it. It's up to you. In our case, if you want to use it, we would say let train name and then pass in some string interpolation here. Cool? All right. Are we clear with what we're doing for practice? Yes? Anybody not clear? I could go over it. Ian. Step 1, add an associated value. We know what an associated value is. We add that to green line. Cool? Step 2, well, it's an int. Step 2, create an instance of it here. Create an instance constant called 5train. And using our train information function down here, we call it like we did down there. We've done it twice. Basically, we're just doing it the third time, but you guys are doing it. And then add a case for green line. Everybody with me? Come on, let's work together and get this done, right? So we could go to raw values. Working together is good in that scenario here. Cassandra, you finished? Any questions? Yeah, tell me. Miguel? We good? Okay. Okay. Anybody want me to slack it out? We good? We in a good place? What happened? Say that again. You have a question? What's the question? Oh, you want me to slack out the question? Excelente. See. All right. I'm not going to go over it. I'll just go to the next topic. Everybody comfortable with this so far? Any questions? We know how to declare associated values. We know how to extract associated values from our switch statements. We know how to create an instance using associated values. So far, so good? So far, so good? No? Maybe? All right, cool. Let's do the last, not even the last. Let's see, one more thing. There's always one more thing. One more thing before we go to the last thing. I do not want to hear, oh, I've never seen this. Actually, let's do it. Let's create a new enum. New enum. Yes, can we? Over. Oh. Okay. We'll go over the question. So step one says add an associated value to green line, right? Yes? Yes? Okay, so let's go ahead and do an int here. So far, so good? Step two said create an instance of it. Yes? So let's go ahead and create an instance right here. I think it was called 5train, correct? So 5train, great, and then MTA line dot green line takes an integer. We say it's the 5train. Great. Cool? All right. Now the next step says add a new case. So far, so good? So let's add a new case here. I'll add a case. I will say green line. And I will say print. I will extract the green line. I did not even give us that as a requirement. That wasn't required. So let's just actually just say print you're on the 5train. Maybe stop at Bowling Green. And take the city walk. Right? Cool? So far, so good? Next step was to use the function and pass in our instance. Don't I need to? This is not a requirement. It's not a requirement. We did not do it for red line. If we want to do it for green line, we can. We could simply say let train name. So far, so good? And instead of hard coding 5 here, I could say train name. Cool? So far, so good. Any questions? We did it before, so the goal was to go to raw values, right? But yes, you could extract it as well. Okay? So here we have you're on the 5train, and now let's call the function, right? Last step was to call the function. Anna? Right, so let's go ahead and call the function. So here we say train information, and we pass in, what line do we pass in? 5train, thank you. And go ahead and run. How many instances do we have here? Or how many instances do we create of train? 3 instances, right? Okay, good. So run our playgrounds, and we do get you're on the 5train. Anna? Right? You on the 5train, maybe stop at Bowling Green and take a city walk. So far, so good? Okay. And a mini, you don't have to use the associated values. We're showing you how to use associated values, right? But if you see some code and it says, does that compile? It doesn't have the associated values, it compiles. It's not an error. But we could use it to extract the value. Same as the train name on yellow line. Cool? Okay, great. Any questions? I'll stack it at the end. Okay, so cool, let's keep going and let's talk about raw values. Let me stack it out now. Slacking out, slacking out. Cool? So far, we've only seen associated values for the first thing today, correct? The rest was review from yesterday. We get to create the next enum again. You might have it in your, let's see, you might have it in your notes already, which is fine. You know what, let's create a new one. I don't think, did we create programming languages yesterday? Okay, so let's create programming language. So we create an enum, it's called programming language. We'll put some languages in here. We'll start off with our favorite one. We'll go to Matt's favorite. We'll go to my first love. That's a Google language. That's a functional language. Functional programming. Okay, cool. We good? All right, so we have programming language, and we have some languages here. We have Swift, Python, Objective-C, Go, R, Java, JavaScript. Right? Great. So now we know how to switch on it. What we haven't seen is functions or methods in an enum. An enum, as I said earlier, is a complex type. I could make it as complex as I need it to be. Right? I could add computed properties in there. We haven't seen computed properties. I'm not going to do it today. But you could have computed properties. You could have initializers. But we've seen methods. We've seen functions. I will add a function here. I'll start out with the func keyword. I'll say info is the name of it. All right? Functions we're familiar with. So far, so good? Our programming language enum now has one method. This is a function, right? We know it's a function. It's called a function. But anytime you have a function in a type, whether it be an enum, right? Whether it be a struct, a class, at that point it's known as a method. Everybody with me? They're the same thing, right? It's a function, but in that type it's now called a method, right? Inside of our enum here. A method, yeah, I'll write it down. So this is a method. So functions in custom types are called methods. Methods. Cool. So a function in a class is called a method. A function in a struct is called a method. A function in an enum is called a method.
So enums, classes, and
Structs. Custom types. Yeah.
So once the functions are inside,
It's just a terminology thing. It becomes a terminology thing. It becomes a method. Yeah.
and you can also go back to that index, like versus program language.
Programming language. Programming language is the name of our enum. Yeah, the type. Yeah. But that type has, like you see when we have our array dot split, for example. I'm like losing track here. When we have our functions on our arrays, those are called methods, right? When we look at our API for array or string or whatever, those are called methods, right? When I say string that components of is a function, but they're referred to as methods, right? That's it.
Does that also go with switch cases?
Switch cases, no. Switch cases is its own thing. Yeah, it's just those three types we'll be discussing in the class. Yeah, that contains is a method. It's a function, but it's, yeah. Does that make sense? You'll get those mixed up. I don't think it's an interview question necessarily, but just get used to calling those things methods. They're functions. Cool? All right. That's a little tangent there with like method names. Okay, here we have an enum, we have a function in it. So far, so good. How do we go through a enum? How do we go through the cases of an enum? How do we switch, right? So thank you, Mr. Jahid, in the meeting. So here we use a switch, right? We use a switch, right? Everybody with me? What are we switching on? Who said self? This guy. What are we switching on? Programming language, yes. What? On one of the cases, that's right. What's the case? The case is a programming language, right? And as Adam is saying, we want to switch on programming language, right? But we want to switch on an instance of programming language, right? I want to switch on an instance. We need to switch on an instance of programming language. Yeah, you can just have case without anything. That's a compiler error. Yeah, you gotta give it some sort of instance, right? That's the question of the day. What do we put after switch? Right? Again, I'm trying to go into that really slowly. Here. Because what we're switching on is ourself. Right? We're switching on ourself. Whatever comes into this function, you see our function doesn't have a parameter. We see that? There's no parameter in the function. Do we see that? So whatever I'm switching on is myself. It will take a bit of getting used to it. We'll talk about it tomorrow and the day after that and the day after that. And you'll still be confused by it a little bit, right? But self, I want to switch on self here. Actually, switch on self like that. Self keyword, right? Self is whatever instance called our info method. We'll see it in an example. So I create some instance of my programming language. I call it Swift, whatever. I say swift.info, right? By saying swift.info, that info here calls our function info, right? Everybody? By calling that function, I'm telling info, I am the one you should be switching on. Right? I am the one you need to switch on. That I there is self. Okay? We'll come back tomorrow. We'll read the notes. We'll come back and talk about self. Right? We'll see what the code looks like. We'll still be a bit lost. That's fine. Yes, but it's an instance of it. But it's the same as programming language. Yes. Self there, yes. Yes. Self knows itself. Its instance coming in. Let's make an example, and then that's going to be a little clearer. Go ahead. I know. Write self, and then we'll come back to it, okay? For now, write self, we'll come back to it. Okay, everybody? Okay, so here we switch on self. For now, assume self is like, again, like it could be like a train or whatever. It could be Swift. But now just say self. We'll come back to it. We'll come back and explain what it is. But self is I'm switching on myself because I'm the one that called that function. Okay, we'll see what that means in code. So here switch, we'll say case dot, we won't go through too much. We'll just do Objective-C, print something here for Objective-C. We'll do Swift. We'll print something for Swift, and then we'll do Java. Print something for Java, and then we'll go to default. All languages are fun. Okay, Objective-C. Last major update was in 2014. Swift was introduced in 2014. Java is used to build Android apps. Also heavily used on Wall Street. Okay. So far we're comfortable with the function, the func keyword, info, the name of our function, empty parents, no arguments. The one bit of confusion is the keyword self. So self is the instance that calls info. We know what instance is, right? We started talking about instances yesterday, right? I created an instance of our empty info. It's called green line or G line, whatever it was. Everybody? Everybody? If we're not sure what instance is, we could review it. Anybody not sure what instance is? Okay, cool. Have we typed that code out? Okay, let's go up. We created 3 instances. We all agreed earlier. We created 3 instances of our empty line here, line 24 to line 26. We agree with that, right? The first instance was the R tray. We created it. That's an instance, our new baby, right? We created our new tray. Everybody with me? You create something new, it's called an instance. The first instance of train, of empty line we created, it was called R train. Instance number 1, baby number 1. Number 2, we created a second instance. We called it one train. We created an instance by using empty line dot readline. We passed in number 1. Everybody with me? Second instance. Third instance we created was called 5 train. Right? We instantiated it with green line. We passed in 5. That's our third instance. We have 3 instances of the empty line here. So here, instances are creations. Instances are constants or variables. This could be a variable. So here we have 3 instances of MTA line below, namely our train, 1 train, and 5 train. Cool? So that's an instance. Everybody with me? Everybody with me? Yes? Should we go over it? I could go over it again. Tiff, you have questions?
No, no.
No? You know the instance. What's an instance?
And this is the creation from my
Okay. All right. Good. All right, let's go on. So we know what instances are, correct? Okay. In order for me to now call my info, the only way I could call this info function here, the only way I could call info function is to create an instance of programming language. Do we agree? Why do we agree, Matt? Okay, very good. It's within the Enum. We have to create an instance of programming language in order to say instance.info. Everybody with me? We really need to read notes because from now on it's going to get even harder to conceptualize what we're doing in programming. We'll start talking about static types, class types, right? What am I repeating? Which part? Oh, the only way to use this function here, outside of the enum, is to create an instance of programming language. Yes, sir. Say that again. Say that again. Sorry.
The function, like up until this point, things that were stored in the enum were specifically cases. Is it okay that it's not located in case it's kind of just there?
The enum info.
No, the function info within the enum.
Yeah, that's fine. Because the only way we could access it is to create an instance on it, which we will do. We'll create like some Swift instance or whatever, and then it switches on itself in order to actually print the case. Cool? Cool?
So we would have to create the instance before, like in the enum.
Outside the enum.
But isn't the, so the enum is closed and then the function?
Everything in that enum now is a definition. Everything in that bracket here is a definition of the enum. For the enum to be useful, we have to use it. For us to use it, we have to use an instance of it.
Oh, so
It's a scaffold
so not to call it in the function, we need to call it.
outside.
Oh.
Yeah, cool? How do? So here we have an enum, that's the definition of the enum. Everything in the body, everything in that curly bracket to the closed curly bracket is the definition. This is how I want to build my building. I want to have a case Swift, a case Python, right? But in order for somebody to actually use my blueprint, I need to have a physical worker there. The blueprint can't read itself. Everybody with me? Right? I need to have some architect or some contractor to come get that blueprint that I did to use it. I can't use this without an instance. Everybody with me? Right? We haven't spoken about class methods, right? But please read. When I say read, read ahead. Those things are getting harder and harder, right? So a couple ways you could, I'll just put it out there, a couple ways you could access a method is through an instance, right? Or through the class itself, right? We'll get more into it tomorrow with structs and classes on Friday, right? But please, I told you guys, the language guide should be the Bible. I'll slack it out again. But we have to read on the train. It's good reading time. I love reading on the train. So here, enumerations. And then for tomorrow, we'll start talking about structs and classes. Right? And here, if we just do a simple self search here. Okay, please at least browse the structs and classes on the train between tonight and tomorrow. Cool. Okay. Now let's create the instance of our programming language. We all have the function info, right? We all have the function info, the method info. Okay, good. Let's create an instance outside. Madam, you're having such a good time. Okay. All right, so let's create an instance of our programming language. We will call it Swift language. And here we use programming language, Enum. And we use Swift. Cool. So here we have an instance of programming language called Swift language. Right? So here we have Swift language is an instance of programming. Hello, David.
Hi, bye.
Programming language. Cool? So Swift language is an instance of programming language. Great. Perfect. So we said the only way we could access info is how? Through an instance, correct? So now we'll use dot syntax to access info. We've been using dot syntax to access a lot of methods in Swift, right? We have array that contains, right? String dot lowercase. So here we have Swift language. How do we access info? Dot. Right? It comes up. Look, we have it there. It's a method. You see M there? You see the M to the left? It's a method. Do we see that? Right? So let's use our method. Great. Now let's run our playgrounds. And let's see what case comes up. Look, it says Swift was introduced in 2004. What's that? Right? So there we go. So we were able to create an enum. We were able to create a method in the enum. We were able to create an instance of that enum. And we were able to call the method in that enum by using dot syntax there. Right? Again, the more we build upon what we know, the more apps we could build. Right? We're here to learn the fundamentals, to put all that together, to build full-fledged apps. Yes?
So question, how come we can't do like, how come we can't do programming language that's Swift that
Programming languages that Swift. Like this.
yeah, like how come you can't but why is it?
Well, you have to create the instance first to access it.
So you have to create a variable for that particular
Exactly. Same like with an array. Like if I have an array, I can just say array that contains like that.
No, I'm not understanding.
No, that's good.
But why is that? Why do you have to
Because certain methods are instance methods, and certain methods are class methods. Right? We'll get into that more. I don't want to start losing people.
and info is just the function?
Info is just a function. We use it by using the instance of it. Right? If you want to say programming language.info, if you want to say programming languages.info, for example, right, I could say like static. I'm not even going to go through what I'm doing there. So static, I could say some information. We'll talk about that later. So I could say some info like this. Right? Tiffany? Right? I could say some info like that, expected function static. I need a func keyword, of course. Right? I could have this and say programming in programming language dot some info. Because I have the static keyword. Right? I'm not gonna talk about it today. But that's how you could access a function directly. By using the class name. Or not the class name, but the type name. Okay? Alright, so purposes of today, we just want to keep it simple. We have an enum, it's called programming language. We have a function, it's called info. We access info through an instance called Swift language. Everybody with me? Okay. And I'm able to print info by saying Swift language.info. Everybody with me? I do not parse in any arguments here. Let's talk about that one. That one is more important than class methods right now. I do not pass in any arguments here. Do we see that? Because this is an instance. So when it calls info, let's walk through the code. When it calls info, right, it goes into the function. It sees info here. It replaces self with whatever, Swift, for example. Everybody with me? It comes down here. It sees Swift. It prints Swift was introduced in 2014. Everybody with me? That's what happens. That's what happens to the compiler. That's why we have the self keyword there. Right? Again, let me do it again. What happens when the compiler, when this function calls, right? So what's that? Yeah, we create instances outside of the type, right? Because that's where we use them. Yes, with that instance. Very good, Amini. Love it. Now let's go again. Let's go again. So on line 76, everybody follow with me. We call our info method. We agree? By using dot syntax. Our info method goes ahead. It goes to the enum. It calls info. Everybody with me? Right? There's no arguments. It switches on that instance, meaning it switches on Swift. Right? Everybody with me? It goes down to look for the case where Swift is. In that case, it sees Swift on line 64. Everybody with me? Then it prints out Swift was introduced in 2014. Do we see that? So that's why here we use the self keyword. Because it could be any instance. It could be Java. Maybe we created a Java programming language. Everybody with me? So that self replaces any instance that came in. Yes.
Function inside the enum, we did it for, like, it makes sense to have more than one function.
Oh yeah, you could have many functions here. I could have a function. Yeah.
If you have one, you don't really need it because you can just call for instance without.
Exactly. I could have a next function here called like I could have a next function called whatever salary info maybe, right, like that, right, where you put some programming language and give me the salary info. Does that make sense? And then in that case, for example, we could say case switch. We could switch on it on self, and then say case Swift.
We can name them the same.
What do you mean? What do you mean? No. So here I could say print whatever. $1 million. Okay, for you $1 million, sure. $1 million starting salary. Great. That's for Luba. Luba wants that. And then we need a default, right? So far, so good. So we have a default here. um, right? Cool. So far, so good. So here I could say my Swift language. Now I could call salary. Salary. And then print. Right? Cool. And if we create a different instance, actually, you guys go ahead and create an instance of any other programming language but Swift and get the salary for it. So create a programming language that's not Swift and call salary info. Cool? So create a programming language instance. Let's really use that name for us to drive it home. So create a programming language instance that's not Swift and call salary info method. Oh, sorry, what's that? I guess this is good. Okay. Yeah. Yeah. Oh yeah, we're just using yeah instance to get the information for that language.
You can use, like how you said before, it'll be the same.
Yeah. You could call multiple methods, whichever amount of times you want.
So now what if you want to, but we can only, or if you want to call it, you can only call.
You could call this multiple times. There's no limitation on how many times you call a method. Or in which way you call the method. It depends on the logic of the problem.
But it will be attached to Swift though.
Yeah, because that's the instance,
When
exactly.
you call it.
It's still that same instance, yeah, it's still gonna be Swift, yeah. But now I wanted you guys to create a different instance.
Not for that. I was
Yeah.
trying to be like,
What? Yeah. All right, cool. How we doing? We good? Mr. Greg, you standing room only? You good? Okay. All right, so cool. The question was create a programming instance that's not Swift. Okay, so here we have Java language. And we're using programming language Enum to create it. And we're saying it's Java. And we're calling Java language dot salary info. And we print it. And it says you're wasting your time, right? According to what we have in our salary info method, right? If it's not Swift, then we get this printed out. Okay? So far, so good? So far, so good. Any questions? Cool. All right, let's see the last topic of the day. Hold on, do we see it yet? No. I think I wrote it though. So this is not raw values. This is using or declaring methods
so
inside.
Yeah.
Yeah. You could do more things in there. And feel free to do it. Feel free to play with it. For sure. You could have a case for Java, yeah. All right, so this is declaring methods inside Enums. We have our Enum here. We declared a method called info. We also declared a method called salary info. Right? Great. So let's go all the way down and create the last topic of the day, which is raw values here. Yes? Okay, I'll go back up. We had raw values up here, but we ended up going into a method and creating a method. So change your title to say declaring methods inside of Enums. Cool? You're welcome. And now we're dealing with raw values. So Enums, there's two ways to associate or to have values with them. One is raw values, and the other one we saw earlier is associated values. Associated values, we saw how to declare it, how to use it, how to pull it out from the switch statement. So here we'll see raw values. No, we haven't done raw values at all. Methods inside of Enums. What we just finished was methods inside of Enums. So now we'll do raw values. We'll start out with day, an Enum called day. Right? I think yesterday, what did we have? Days of the week? So that shouldn't conflict, right? So here we have day, and we say Monday, Tuesday, yeah, in that case. Yeah, you need cases before the names. Sorry. Cool. So here we have our days of the week. All great. We saw how to do associated values before. We could have done an integer here, for example, right? Don't type it in. But that's associated values. Now we'll see what raw values look like. We could start out with a raw value by declaring the type of raw value is going to be. So here we've declared that the day enum has a raw value of integer, right? So now we could associate the cases with integers, right? Let's see what that looks like. So now if I say print day dot Monday dot raw value, already we see it's an integer. If we say dot raw value, as the name implies, it's the raw value. Get me the raw value. Don't get me Monday as Monday. Get me the raw value. Extract me that value inside of Monday. Don't get it confused with associated values. This is different, right? So here we have raw value. Let's see what the value of raw value will be. Go ahead and run it. Right? So here the default of an int, default starting case of an int raw value is 0. Same as arrays, right? Arrays start with 0. That's good, right? The language has some consistency. Arrays start with 0. Tuples start with 0. Our favorite topic, closures, the argument starts with 0, right? So there's no like inconsistency there. So here, if you do not explicitly say what this guy should start with, what does it start with? 0. But the flexibility of Swift, right? We could change what the starting number is. I could say 1. And now if I run my program again, wait, what am I having there? What am I doing? Oh, sorry, 1 does not go here. I'm thinking default values for functions. So here, if I have 1 as the default value, and I go ahead and run my program, it starts with 1. Everybody sees that? Right? So I could say what my case starts with. If I do not explicitly say 1, what does it start with? I could start with any number. What if I want to start with 2? That's fine. What, in that case, what will Tuesday be? 3. Yes.
In this case, raw value is a property.
Raw value is an extension on Enums, adds more functionality. It's not a property per se. Oh, you mean on Monday? Yeah, when you have a raw value, you have access to that raw value as a property, yes. Yes, thank you. Okay, so here we have Monday being 1, and we have Thursday being what number?
4.
All right, everybody sees that? So it increments that value. Everybody with me? Great, great, great.
So once you put the first one, you don't have to put.
No,
But what if you wanted
to put 4 here?
to?
5?
You do that?
You could do that.
Or
Right.
what if you wanted them to implement by like 4, 8, 12, 16?
You probably have to do case iterable and do some extra logic on there. All right, cool. So we saw, and we are not restricted to integers, by the way. We could say string. Everybody with me? I could say string here. Everybody with me? I could say string, and in that case, I could say Monday, fun day, right? And let's go ahead and print what the row value looks like. Right, so Monday, fun day. Do we see that? Right? So depending on what you want to go for here, you could have a raw value on your cases.
So this is instead of doing a switch case?
Not instead of doing a switch case, instead of doing associated values. You still have to switch on this. Yeah, you still have to switch on that to find out if it's Monday indeed. Right? So we still have to switch on it if we have to do anything. Actually, let's hold that off. Let's do something else. 1 second, go ahead.
I noticed you wrote string, but you didn't write it for the other ones. What day you don't like declare it?
It's not. It's just gonna have Tuesday. Like, let's see what it comes out to be, right? So print day dot Tuesday dot raw value. It just comes out as Tuesday.
I understand what you get rid of the string, the type string,
Oh, the type string. It's still gonna be. It's gonna be just Monday.
but you can mix it up with int and string
No. The raw value needs to be consistent. Type safe. It's type safe.
Oh,
Yeah.
that's-
Remember, Swift is type safe. You can't do corners like JavaScript. There's no corners there. You start with something, you have to continue with it, which protects us from ourselves.
And if you don't declare it, the first case decides whether or not it's any sort of string, depending on what it is.
If you don't declare any raw value, you have no raw value. It's nothing. There's no raw value there. Right? If I do not have, let me just create the next enum here. So enum fellow, for example. Case cohort cycle, for example, right? And if I say print fellow dot cohort cycle dot raw, you see already I have no raw value. Let's keep going. Value. Right? Value of fellow has no raw value, so it does not compile. You see that on a midday check-in, does not compile because I did not specify a raw value here. A raw value, you assign it, you have to assign it a type. I have to say, give this some sort of type, an int, a bool, a string, a double. You with me? Okay. If I don't specify a raw value, what? You got it?
No, you didn't in programming language. That's why I figured.
Programming language. Programming language. What exactly are we talking about?
In the Enum programming language,
No, I didn't. There's no associated values there. There's no, I'm sorry, raw value there. Right? We have no raw value. We did not talk about raw values yet. Cool? Different topics. That's why we try to have the headings. I know there's a lot. So we really make sure we have our headings here on our playgrounds. Yeah, very easy to lose track of what exactly we are. Yeah.
So you cannot have, let's say not even for this one, but even before, as I was doing that, right?
So remember, let's keep that and say does not compile, right, everybody? Hello? Does not compile. Thank you, Mel. Exactly. So no raw values applied or provided. Cool. Question, Tiff.
Yes, so I was noticing that even before we did for Untitled, right, where we had red line was in, green line was in, yellow line had in, but also had character.
You could mix and match the associated values.
That's what I was gonna ask. So you can have red line as an in, green line
Yes.
as a string.
That's good. So already you see it's more robust, right? You could do more with associated values.
Right.
You see, right?
And what about if you didn't have it the way that you do, the way that we have it now, where we
You can mix and match you can mix and match that one.
even if you put any,
No. Well, I don't think any works with this. Let's see. Any type, let's see, put a string here. Right? Enum case cannot have a raw value if type does not have a raw value. You can't do any here. It has to be a complete type. All right, so here, go back to int.
it gives you a blank,
If you keep it blank, you don't have access to raw value
you can mix it up with int and then
if you make associated values. Associated values, you could have different values on that case. Raw values, you need to start, whatever you start with is what you continue with. Cool? Does that clear up a little bit? All right, cool. Associated, you could have any mix and match there. I could have, as with the MTA, I had an int, I had a character. We saw that? With associated, with a raw value, you declare, this is an int. It's like our array, right? Our array, we say it's an int array. You can't have a string in there. You with me? Okay, cool. Good. Let's see. Let's see initializing. That's a good one there. So let's see initializing a raw value. Initializing an instance of an enum with a raw value. Okay, so we have, let's create, where am I? So we created our day. Oh, the topic. We should probably make a bigger topic, right? That's a big topic. Let me get a bigger topic because this one is good. This one is called initializing an instance. Initializing an instance of an enum with a raw value. So here we will have weekday or weekend. Starts out with a day. Starts out with a day, and I want to say, right, so it starts out with the day that we created here. Not the weekday, by the way. What did you call it, Julia, yesterday? Right. Not day of the week, guys. You might have a day of the week in your playgrounds. Everybody with me? I'm using day here, the day we just created. Open parens. The minute you have open parens, what do you see? One of our favorite things in Swift. Optional, right? We love optionals. So we have an optional day here because guess what? That day might not exist. How many days we have in the week? Somebody hesitated there. They're like 6. Sunday is off, but not off the calendar. Okay, so we're returning some optional day here because I could have 10 in. What if I do this? Does that exist? No. So it returns as an optional. That's why optionals are very important in Swift. If the thing doesn't exist, don't return me any value. Just return me nil. It doesn't exist. So here, how do we unwrap a optional? Just give me one option. We'll go for it. Nil coalescing is one way. So we could say nil coalescent. What default are we giving it? We have to give it a default day. 0? What's the compiler going to say? Will it be happy? Compiler says, cannot convert value of type int to expected argument type day. Those are different types. 0 is what type? Integer, right? What type is day? Day, right? Those cannot work together. So remember, when you're using nil coalescing, that default you give it has to be of the same type. Everybody with me? So here, yeah. We haven't done anything yet. The only thing we've done here in that particular line, 122, is say, create a constant, call it weekend.
No, but when you go up to what you have as day, did you put it as an int or anything like that? Or did you leave it as
Day is just int.
So then day is an int.
Yes, it is.
So then how come it be like
But 10 here, day is an int, but the 10 here, remember, when you count from 1, right, where do we stop? Count the days we have. 7. Do we have a 10? No. So based on the code we're writing right now, this does not exist in our enum. The value 10, the raw value 10 does not exist. We have a raw value 1, we have a raw value 2, 3, 4, 5, 6, 7, right? But 10 does not exist. Does that make sense to everybody? No. We're not done yet. There's an error there on our screen. Oh. You probably haven't nil coalesced. Okay, cool. So here, when we do nil coalescing, guys, please remember, if you're trying to nil coalesce whatever type, the default type has to be what? The same type. Period. So here, I could say like day. I could give it a default day, like day dot whatever it's Saturday. Right.
so sorry, when it does weekend day raw value, so basically it's just using the raw value to get to the day itself.
Yes. Exactly. Very good. What's happening? Question? Adam? That's what I said. So, we have 2 day enums. We have one called day of the week. That's why I started. Make sure we're using the one called day. Are we all good? Okay. So here, if I print out weekend, print weekend, like that. Go ahead and run it. Stop and run again. What are you guys printing? Finally came back to life.
So I noticed, right, for the Enum, once you put a variable, the one that comes right after it will be, the coming out of the number, the number coming after will be the exact number. But for example, for Sunday I put 1, and I didn't pick for Monday. For Tuesday I put 4, and I didn't pick for Wednesday. But it's going to tell me that Monday is 2 and Wednesday is 5.
Okay, that makes sense. It increments and then it changes. Yeah. Okay, everybody got Saturday printed? Okay, why did that happen? Because 10 doesn't exist, right? Josh, you got Sunday, you said. What did you put here? Day dot what?
Saturday.
And then what did you put in here? And you got Sunday. Where do you start your count with your int for Monday? What's the count on it? Is it 1?
Yeah.
Are you on day?
Yeah.
And you have Monday through Sunday. And then you have Saturday, Sunday, in that order. Or do you have Sunday, Saturday? Okay, we'll double check your screen to see what's going on. Right? Okay, everybody got Saturday, correct? Make sure you're using day, Josh. Are you using day? The variable day, the type day. Okay, we'll double check your screen. Okay, cool. So we all satisfied that if we put in 10, it doesn't exist. It takes our default. Everybody agree? Right? Let's see how to do it using optional binding. So here we're using nil coalescing. So nil coalescing to unwrap optional raw value type. Cool? So let's see how to do it with nil coalescing, and that'll be a wrap for the day. So here we'll use optional binding, So optional binding. To unwrap optional enum. All right, cool. So let's create other day or possible day off. Right? Optional binding, how do we start our optional binding? How do we start optional binding syntax? If let, right? So here, if let something exist, the something that exists is the day that we created from a raw value, right? In that case, we'll say 4 or 6, right? Else, it doesn't exist here, correct? In the else statement, it doesn't exist, right? Everybody with me? Optional binding, back to optionals class. If let unwraps it, everybody with me? If it exists, it goes in the if let statement. If it doesn't exist, where does it go? In the else statement. Okay, so here we'll say print possible day off dot raw value. Actually, let's switch on it. Let's make it more interesting. All right, so here we'll switch on possible day off and use some cases. We'll start off with Saturday, print, and then we'll do Sunday, And then we will have a default. Great. So Saturday, we will say cool. And default, you could still see the entire screen. That's good. In our else statement, we will say not a valid day of the week. So here we're using optional binding. Already we see optional binding gives us the else case, so we could have a print statement here saying, hey, it wasn't a valid day, right? We're using our switch statement. If it's a possible day, we switch on it to see what day it is, what day of the weekend, right? We could have more cases in there. If you have all the cases, do we need a default? No. Perfect. If we have all the cases and we have a default, what happens? It will never, right? So that's a warning. We get a warning, not a compiler error. Okay, everybody? We get a warning if we have all the cases plus a default. It will still work, we'll have an error. I mean, a warning, sorry. And we do not submit codes with warnings, right? Warnings ultimately become errors most times in the language, so be careful there. All right, great. So now let us run this. We still have the whole screen, so we could keep typing. Great, so great day for a barbecue. It's Saturday. Everybody has that? Right, so I created a raw value. I used a raw value to initialize the day. I passed it 6, which is valid because we have 1 through 7, correct? We have our int raw value, 1 through 7. We use 6 to initialize our day. We use optional binding because we know that it could not exist. There's a possibility. If I put in 100, that doesn't exist. That's not a valid day. So we have to use optional binding or nil coalescing to unwrap it. We unwrapped it. It successfully unwrapped. Our possible day off now has a valid value. So we went ahead and we used a switch statement to switch on that enum here. And it happened to be the 6th day, which is Saturday. It comes in and prints great day for a barbecue. Cool? Adam, you have your hand up. You stretching or? You're stretching? Okay, long day. All right, cool. So we'll end here. And this is the end of Enums for now.